All right. Hello, everyone. Let's take a look at special case systems. I'm going to solve these systems with substitution. And the great thing is, I already have a y equals. My y is equal to negative 3x plus 2, so I'm going to plug it in for y in the second equation. So everything in the second equation is going to stay the same. And wherever I see a y, I'm going to replace it with negative 3x plus 2. And that is also going to equal 5. Combining my like terms, I have 3x minus 3x, which is 0x plus 2 is equal to 5. And 0x times 0 and 0 plus 2 is just 2. So then I'm left with 2 is equal to 5. Since this is a false statement, the system has no solution. And if I were to think about this on a graph, that means there is no place on the graph where these two lines intersect. That gives us no solution. In the second example, I already have my y isolated, and my y is equal to 1/2 x minus 1. And I'm going to substitute 1/2 x minus 1 into the other equation. When I substitute that in, I get x minus 2. And I'm going to go ahead and plug in my parentheses, 1/2 x minus 1. And that is going to be equal to 2. Now when I think about this multiplication in the distributive property, I'm going to think of this x minus 2 times the quantity 1/2 x minus 1 as plus a negative 2. I want to think of this number out front as a negative 2. So I have a negative 2 times a positive 1/2 x. So a negative times a positive is a negative. Half of 2 is 1, so I have left with x. And here I have a negative 2, and I'm also going to think of this as a negative 1, because subtracting 1 is the same thing as adding a negative 1. So then I have a negative 2 times a negative 1, which is a positive 2. And that's going to be equal to 2. And then combining my like terms, x minus x just gives me 0x plus 2 is equal to 2. And that simplifies to 2 equals 2. So here we have a true statement. And for true statements, it actually means that the lines are exactly the same. And so a system to a solution is what ordered pairs make both equations true. So here we're going to write all real numbers on the line. Y is equal to 1/2 x minus 1. So that means there are infinite number of solutions, different order pairs that make both equations true. Any point on that line is going to make both equations true. So there we have our special cases. We have an example of no solution, where the lines never cross, so there's no x and y that make both equations true. And the second, all real numbers, where if you graph it, it's the same line, and so every single ordered pair on that line makes both equations true. Thanks for listening.